Welcome everyone. So in the last couple of videos we saw just I will say till now what we discussed on the before video lectures. So initially we discussed about what is the control systems, what are the general blocks in the control systems, and also what are the components, and after that what is the open loop system, closed loop system. After that the mathematical modeling of a mechanical system separately, mathematical modeling of a mechanical rotational system separately, mathematical modeling of a electrical system, and the transfer function of a DC servo motor. Till now we concluded all these three, sorry, all these things. So now we are going to discuss about the transfer function of a AC servo motor. The thing is the AC servo motor. Basically, DC servo motor and AC servo motor both are a little bit of different. So both are a small and also small in size and also low in cost. But the thing is, the supply will be different, and also the AC servo motor have a little bit of other two connectors like the encoders with respect to two encoders and decoders will be there. If you see here, just a minute. Yeah, if you see here, encoder connector will be there, which is related to get the information about from the motor, because it is already completely fixed what one, and also there are some encoder covers, each and everything. So these things are a little bit of different, which is not available in the DC servo motor. So because of that things, a little bit of differentiation will be there compared to the AC servo motor and DC servo motor. Okay, so in this video we are going to discuss about what is the AC servo motor, what is the transfer function of the AC servo motor will be in the next video lectures will be there. So AC servo motor. If you see here, the AC servo motor, it is an in-depth inside information of the AC servo motor. So one is related to the encoder. So if you see, this is related to the encoder, and this is related to the cable, which is going to get information from the motor, whether it can be a speed, whether it can be a torque, whether it can be angle, whether it can be anything, whatever the information it will be, whatever the voltage passing or current passing towards the motor, inside the motor, all this information is going to be collected through these two cables only. Okay, and after that we are going to see what exactly is. We see here, it is an essential system at the same. They are going, both AC servo motors and DC servo motors are utilized in the aerospace, robotics, and everything, wherever the automation is required. But the thing is, it depends upon the supply, and it depends upon the controller which is going to use. If the controller is having more number of pins and more uh, accuracy is needed, means then automatically AC servo motor is going to use. But when it goes to the low supply, different DC supply, then we are going to use the DC servo motor. So if you, the basically the AC servo motor is a special purpose motor. Actually, DC servo motor will come under the DC motor classification, but AC motors will come under the special purpose motor classification, which is designed for the precise control of the angular position. Whatever that angle position of either clockwise or anti-clockwise or rotation is there, it's a precise control will be there. That means, for example, the 0.5 degrees clock it need to be rotated, means it need to, we can get the precise accuracy in the AC servo motor, and the velocity and acceleration. It usually operates in a part of the closed loop system. Why I'm saying here the closed loop system? Because these encoders will give the information. Whatever these encoders are there, these encoders will give the information about whatever the motor is having. By that information itself, the controller will operate in the closed loop operation. Then after that itself, we can get to know how it need to be operated, and which controller which need to be operated, which control algorithm we need to operate. This is how the AC servo motor will be operated, and it can offer a high speed and high accuracy compared to the DC servo motor. But the DC servo motor will not have that much of high speed. There will be limited speeding applications will be there. But when it comes to the AC servo motor, we are having a high speed applications, and a high accuracy is able to possible. Okay. Now you see the key differences in the both AC servo motors compared to the DC servo motors. If you see, this is a DC servo motor and this is the AC servo motor. So we are seeing the what is the key differences when compared to both these things. So unlike DC servo motor, AC servo motor typically use sinusoidal voltages and sinusoidal, as it is already the name itself having a AC supply. So it is only uses the AC sinusoidal voltage, sinusoidal current. But in the DC we don't have that one, and they are also brushless. AC servo motors and everything are brushless, and high efficiency will be there, and requires more sophisticated control. As I already said, the control algorithms need to be very accurate, need to be there, and very perfectly we need to decide. Otherwise, it what will happen is the accuracy is not coming, which is nearby equals to the DC servo motor itself. So that's why the sophisticated control is very much needed when it comes to the AC servo motor. But when it comes to the DC servo motor, that much of control is not needed. As we already know, whenever we are working on the AC, the control algorithms will be a little bit of complex, little bit of sophistication will be there. Okay, and now I'm just pausing the video here, and the next video will be related to the transfer function, which is in I divided into two parts because the presentation is having a mixed one, so I'm dividing into two videos of the transfer function. Okay, thank you.